Hi, welcome to Blockchain Mining. My name is Andrew Prokop, and today I want to introduce you to the fundamentals of blockchain as well as discuss blockchain mining. Specifically, I want to talk about how Bitcoin uses mining to add Bitcoins to blocks and those blocks to a blockchain. While you may never have any use for cryptocurrencies, the concepts discussed here are useful in developing a fuller understanding of blockchain in general. Blockchain is a fairly new technology. It was invented in 2008 by Satoshi Nakamoto. In reality, though, Satoshi is a pseudonym for a person or a group of people. In other words, we have no idea where blockchain came from. Blockchain is a process of creating validated blocks and then distributing them to a decentralized public ledger. This means there is no central repository for a blockchain. It exists simultaneously on many computers, potentially scattered around the world. At a minimum, each block contains a cryptographic hash of the previous block, a hash of the current block, a timestamp, and the transaction data. As you will see with Bitcoin, a block can contain much more than these minimums. By the end of this video, I hope you see just how hard it is to nefariously modify a blockchain and its blocks. And lastly, this is truly a disruptive technology. This is a very simple example of blocks in a blockchain. I've shown the cryptographic hashes in blue. You can think of those as mathematical representations of the contents of a block, like a checksum. If you change the contents of the block, you need to change the hash. Consequently, if you change the hash and the contents do not change, the block will be invalidated. The hash of each block is calculated using the contents of the block plus the previous hash. This means that you cannot change a block's hash without changing all the subsequent blocks. When I get to blockchain mining, you will see how this plays a large part in making blockchain resistant to tampering. Bitcoin is a cryptocurrency which is a form of digital cash. It is a decentralized currency without a central bank or single administrator. Bitcoins are stored using blockchains with an average of 6.25 Bitcoins per block. While blockchain can and does exist without Bitcoin, Bitcoin is the reason why we began paying attention to it. So, where do Bitcoins come from? No, not from the stork. They come from the same place that precious metals come from. Mines. However, instead of physical mines, Bitcoins are found in digital mines. With Bitcoin, miners use software to solve math problems and are issued a certain number of Bitcoins in exchange for their work. This provides a way to issue new currency while incentivizing more people to mine. Bitcoin miners keep the Bitcoin network secure by approving transactions. This means that a collective of miners must accept the validity of the mined Bitcoin. Note that I am greatly simplifying the details of acceptance, but this explanation is good enough for a general understanding. This is an example of a Bitcoin mining computer. You can go on Amazon and find them for a couple $1,000s to, in this case, close to $20,000. They use specialized hardware that has been designed to solve the cryptographic hash, which then mines the Bitcoin. Central to the cryptographic hash is the nonce. Nonce is short for number once. It is a number that is used one time. You can think of it as a magic number that needs to be factored into a block's hash value. It generates a hash that begins with a set number of zeros. This is often called the difficulty. So if you have a difficulty of 3, that means that your hash value begins with 3 zeros. And the difficulty is recalculated every 2016 blocks. And it has been designed such that a block, which is a group of transactions, is approved every 10 minutes. Here's an example of a hash value. You can count up the number of leading zeros, and that will tell you the difficulty. And it typically requires specialized hardware, energy, and time to guess. To calculate a hash, you use the SHA-256 algorithm. And the SHA-256 algorithm accepts the previous block's hash, the data of the block itself, and the nonce. And the nonce is movable. The previous block's hash and the data are fixed, so it's the nonce that needs to change in order to create the hash value with the correct number of leading zeros, the difficulty. So in this example, I show where I start with the nonce value of 1 and I increment that value. I increment the value one number at a time. So previous block's hash plus data plus, in the first case, 1. And it produced this hash value. And I'm looking for a hash value that is 8 leading zeros. So does that have 8 leading zeros? No. So I increment it to 2 and I recalculate. No, increment it to 3. In my example here, and I wrote a program to do this, I had to increment this block until the nonce became 9,232,323, and then it created the hash with the number of leading zeros. So the goal of mining is to see how quickly you can find that nonce. Now I will tell you that taking this nonce value and incrementing it one at a time is not the correct way to do it. You will find eventually the hash value, but somebody else will find it quicker than you, and that is where the specialized hardware that comes into play that has been designed to optimize finding this nonce value as quickly as possible so that you come up with the correct hash. As I mentioned, I wrote a very simple mining program, and I went through some gyrations to determine what sort of nonce values would come depending on the difficulty. So I started with 1 leading zero, so a difficulty of 1. It took me 5 tries to get the correct hash. I then said, let's do it with 2 leading zeros, so a difficulty of 2. It took me 1,320. 3 leading zeros, 2,532. 4 leading zeros, 3,954. 5 leading zeros, now I'm in the millions. It took me millions of attempts. 6 leading zeros, it took me 26 million attempts to find the correct hash. 7 leading zeros, it took me 108 million attempts. And then with 8 leading zeros, it wasn't much worse, but I got lucky. It took me all close to 119 million attempts in order to find the correct hash. If you go to www.blockchain.com/explorer, you can see the actual blocks in the Bitcoin blockchain. And I pulled out one of these blocks to take a look at it. You can see that the current difficulty is 19 because there are 19 leading zeros in that hash value. And you can see the nonce value that was used to solve this problem. And again, these Bitcoin mining devices are not doing this linear nonce value. They are using an algorithm to try and attempt to find the nonce value as quickly as possible. In this case, you can see that the nonce value is close to 1 billion. I don't know how many attempts it took to get there, but that's an awfully big number. And it took some time and some effort to find the correct hash, which then would produce the block, which then could be added to the block, and then the miner is paid for finding the Bitcoin. Here is an easy representation of blockchain integrity. Let's start with 1. Say everyone is working on block 91, but one miner wants to alter a transaction in block 74. He would have to make his changes and redo all of the computations for block 74 through 90 and then do block 91. That's 18 blocks of very expensive computing, and there's no way that he would be able to make this hack without being caught by the other miners. This mining comes at a cost. The annual power consumption of the Bitcoin network is currently estimated to be 129 terawatt hours. If Bitcoin were a country, it would rank 29th out of 196, narrowly exceeding Norway's consumption of 124 terawatt hours. And that's it. I hope my explanation helped you to understand blockchain and, more importantly, blockchain integrity.